Yo, what's up guys? Patrick here, moving on to another word problem dealing with quadratics. So we have to find the width of a parabolic tunnel that is 10 meters high and 8 meters wide at a height of 6 meters. You have to leave your answer as a simplified exact value. Now this question is fairly unique, one that we haven't done before. And if you remember in previous questions, whenever you were given a parabolic tunnel or a parabolic bridge, I always told you, if possible, you want to put the edge at the origin. So you want to make your bridge or your tunnel look like that, right? The edge is at the origin there. Well, in this case, I actually wouldn't recommend it. And here's why. Look at what we're given. So we're told that this tunnel is 10 meters high. So the max point is 10 meters. And then we're told that it is 8 meters wide at a height of 6 meters, meaning that at a height of 6 meters, let's say it's over here, these 2 points, they are 8 meters wide. And we're solving for how wide this bridge is. Well, the problem with this diagram here is we're given a lot of information about the height, right, about this axis, but we're not given too much information about the x-axis. Reason is that these points here, so at a height of 6, can be anywhere. So for example, this could be like 3 and 11, right? The difference between them being 8, which would change where the x value of this point is. It would be the midpoint between 3 and 11. So 11 plus 3 is 14 divided by 2, 7. But this point can also be maybe at like, I don't know, 5 and 13. Right? Still a difference of 8. We don't know. So what I actually recommend doing is taking this parabola and shifting it. So this max point is on the y-axis. So let me show you. So it looks like that. Because now we know the coordinates of this point. This point has coordinates of 0 and 10, right? That max height is at 10. And then we're told at a height of 6, so right here, the distance between these 2 points is 8. And because this is right in the middle, we know that this has to be symmetric, meaning that if the distance between these 2 points is 8, then the distance between the axis and that point is 4. Distance between the axis and that point is 4. So we know that this here is happening at positive 4 and this is happening at negative 4. So now we know that this point has a coordinate 4 and 6 and this point has a coordinate negative 4 and 6. Right? We couldn't get the coordinates here, but when we shifted, we can. And now what we're solving for is how wide this tunnel is. So what we can do is we can solve for the x-intercept. So let's call it x1 and then x2. And then the difference between x1 and x2 will give us how wide this tunnel is. Right? So in previous questions, usually we're given the width of a parabolic tunnel or a parabolic bridge. Then I would draw it like this, because then you know, if you know the width, this is at 0 and 0, you just add the width and then you can get this point. So if the width is maybe like 11, this would be 0, 0, this would be 11 and 0. And then you have the two x-intercepts, you could put it in factored form, you could work from there. But in this case, we're solving for the width. We're not given the width, but we're given the max height and some other information. So I would then recommend putting the max point on the axis, because then you can actually label that max point as a coordinate. In this case, it's 0 and 10. Right? So hopefully that made sense. So you got to be flexible in making your diagram. Sometimes you're going to put the edge at the origin. Sometimes you're going to put the max point on the axis. So from here, our first step is we want to get an equation for this parabola here that represents this bridge. And notice that we're given the vertex, so I would recommend putting this parabola in vertex form. So it would be what? H equals A. We don't know what the A value is. The X value of the vertex is 0, so the H value here is 0. And this H is different than this H, by the way. So X minus 0 is just X. And then the K value is 10. Like that. So we got H equals AX squared plus 10. Right? The vertex is 0 and 10. So now to solve for this A value, we could either plug in 4 and 6 or negative 4 and 6 for X and H, and then solve for A. So I'm going to pick the positive ones. So 6 equals A. This is 4 squared plus 10. Bring the 10 over. 6 minus 10 is negative 4. This would be 16, so it would be 16A. Divide both sides by 16, so A is negative 4 over 16, which is negative 1 over 4, like that. So we know that the equation is H equals negative 1 over 4. We would plug in the A value there. X squared plus 10, like that. Okay, so that is the equation right there that models this parabola. And now what's our next step? Our next step is we have to find x1 and x2. We have to find the x-intercepts, because once we have the x-intercepts, then we can find the distance between them, and that would give us how wide the bridge is. So how are we going to find x1 and x2? Well, notice that x1, x2, the value of h, the y-axis, is 0. So we could plug in 0 for h. And then we could just solve for x. So we bring the 10 over, so we'd have negative 10 equals negative 1 over 4 x squared. We could divide both sides by negative 1 over 4. So this would be 40, right, equals x squared. Negative 10 divided by negative 1 over 4 is positive 40. Another thing we could have done is we could have just cross-multiplied everything. Either way, we get 40 equals x squared when you do that algebra. So x is what? The square root of 40, but it's plus or minus. Remember, the square root can be positive or negative. So that means x1 here is negative root 40, and then x2 here is positive root 40. So now that we have the intercepts, we can just take this intercept, subtract this one, and that would give us the width, right? Because if you think about it, the way it works, if I draw another parabola here, even though we're dealing with a negative here, let's say this is like negative 3 and then this is 5. What's the distance between negative 3 and positive 5? It's 8. The way you get that is you go 5 minus negative 3, which would be like 5 plus 3, which would be 8. So if we want to get the width here, it would be root 40 minus negative root 40, which would be like root 40 plus root 40. And there's like a 1 in front. Notice that these are the same radicals, so they are like terms, so we could add the coefficients here in front. So 1 plus 1 is 2, so we'd have 2 root 40. That is the width. And this is in meters. However, they want your answer as a simplified exact value. So we have to actually simplify this radical a little further. And 40 is actually divisible by 4, which is a rootable number. So root 40, I split up into root 4 times root 10. Root 4 is just 2, right? And then root 10 we can't simplify any further. So this, 2 times 2 is 4. Root 10 we just leave as is. So that is the final answer. The width of the bridge is 4 root 10 meters. That's the simplified exact value. Right? So again, usually we're putting the edge at the origin, but that's more so when you're given the width of the bridge. When you're finding the width of a bridge, depending on what information they give you, but in this specific case, it's better to put the middle of the bridge on that y-axis versus the edge on the origin or on the y-axis as well. So once you get that, you get these points, you can find an equation, right? So you put in the vertex, solve for the a value, we got this. And once you have the equation, you could solve for the intercepts here. So you plug in 0 for h, you get plus or minus root 40. The distance between plus or minus root 40 is 2 root 40. And then you simplify the root 40, you get 4 root 10 meters as the width of the bridge.